I welcome you all on India's largest live e-learning educational platform, that is Gradeup. First of all the candidates who are joining me, please tell me whether my audio and visual quality is okay for you so that we can proceed for the session. Good evening, Bhargav, how are you? All the candidates who are joining me, you should do two things. Number one, you should like this page. Number two, you should tell me whether my audio and visual quality is okay for you so that we can proceed for the session. And let me tell you that today we are going to discuss one of the most interesting and one of the most misunderstood concept of armature reaction in synchronous machine. I hope all of you must be enthusiastic to learn this concept. Good evening, Benson Thomas, Manikant, Bhargav, Smart, all of you. Now tell me quickly whether my audio and visual quality is okay for you or not. Are you comfortable with my voice and my video? And if you have any doubt, then you can tell me. Good evening, Vaishnavi. Okay, so it is okay, now we can proceed. Now friends, let me tell you some background that we are taking up a startup series for electrical machines. Right now we are discussing the synchronous machine. In the previous classes I have discussed about the effect of salient poles, and in the yesterday class I have discussed the power angle characteristic of salient pole machine. Now today we are going to discuss the synchronous machines armature reaction. Is it clear to all of you? Okay, Bhargav. So everybody is reporting that my audio and visual quality is okay. Now let us proceed for the session quickly. Now the first slide on your screen shows there is a brief introduction about myself, because some of you may be joining me for the first time. My name is Ashutosh Saxena. I have 10 plus years of teaching experience. I have completed my M.Tech from IIT B.H.U in 2010. I have written 2 books, Engineering Ethics and Power System. Engineering Ethics is already in market. My areas of expertise are power system, electrical machines, electromagnetic field theory and material science, and engineering ethics. Okay. Now there is one more important information regarding the Target Gate 2021, the second batch. With the overwhelming response of the students, we have started taking admissions into the second batch. And let me tell you, one of the most important and distinction about this Target Gate 2021, that it is going to be a bilingual course, so that Hindi or English dono mein baatcheet hogi, so that language is no more a barrier for your learning. Rakesh Talreja sir, myself Ashutosh, M.N. Ramesh sir, Vijay Bansal sir and Chandan Jha sir, we are going to take classes in this. Very eminent and experienced faculties are going to take classes. And let me tell you that more than 11,000 people have started the free trial. At least you should start the free trial to know and to experience how Gradeup is changing the life of thousands of students. Is it clear to all of you? Molly Manikant is asking, sir, what hour means what, sir? See, Molly, I think this class is not related to watt hour meter. This is not measurement class, beta. This is electrical machines class. And better to post your doubts in a proper way. In the Gradeup app, if you go from YouTube to Gradeup app, in the Gradeup app there is a categorical section which is called as doubt section. You can name the faculty, you can name the topic, you can name the subject, and you can post your doubt, and it is a guarantee that as soon as possible your doubt is going to be resolved. There is a commitment from our side. Is it clear? Good evening, Goda Kavya, how are you? Now let us see some of the characteristic features of this Target Gate Batch 2. There is going to be 550 hours of live classes, 5,000 questions, practice questions at the level of GATE. And let me tell you that if you are practicing 5,000 questions, only you can stop yourself from getting a 1-digit or 2-digit rank in the GATE examination. And how you can do that? You do not go to the examination hall in the examination date. You do not write the paper, because if you write it and if you have practiced 5,000 questions, definitely you are going to get a very good rank. We are also providing you the study notes covering each chapter and subject in details, full-length mock test for GATE 2021, daily test and subject-wise test. And the classes are going to start from 12th of May, that is today. And this is the contact number. If you have any query regarding anything in this Target Gate 2021 batch, then you can contact this person, or you can write mail to this email ID help@gradeup.co, or you can directly contact our backend team member, that is Anand Pandey. Is it clear to all of you? Now let us proceed with the session. Now how I am going to deliver this armature reaction concept to you, you listen to me very minutely. First I will give you an overall picture what is armature reaction. Then we will try to discuss why these things, for example for zero power factor lagging, why we are reading, zero power factor leading, why we are understanding all these different cases. And then we will have a summary or the conclusion of the armature reaction in synchronous machine. Is it clear to all of you? Please tell me yes or no in the comment section. Please tell me yes or no in the comment section so that we can proceed. I hope you are okay with my methodology. What is my methodology? First I will tell you the overall picture of the armature reaction. Then we will discuss each and every case in detail, and then I will give you a summary or the conclusion of this armature reaction in synchronous machine, whether it is generator, motor, lagging, leading, whatsoever. Is it clear to all of you? Please tell me yes or no in the comment section so that we can proceed. Okay, now you listen to me properly. Now you listen to me properly. The first statement that we are going to understand about the armature reaction is that you please understand what is armature reaction. In simple words we are going to understand what is armature reaction. Armature reaction is made of two words. Number one armature, number two reaction. So armature reaction is the effect of armature flux on the main field flux. That is the first statement we have to learn. What is armature reaction? Armature reaction is the effect of armature flux on the main field flux. 100% clear? Second important point. If you go to the synchronous machine, for a synchronous machine, this effect of the armature reaction, I am writing armature reaction as capital A, capital R. Armature reaction depends upon the power factor of the load connected. Now what is the idea here? You please listen this story. This is very interesting and this is very important. If you don't understand this, then you are not going to understand armature reaction fully. What is this story? The story is, if you go for a synchronous machine, the armature reaction is going to depend upon the power factor of the load connected. What is the meaning of power factor? Power factor means the cos of the angle between the voltage and current phasor. Till now if you understood this, then I am going to tell you one very important point, one case. What is that case? If the armature reaction is going to depend upon the different load conditions in terms of power factor, and if somebody asks you what is the nature of armature reaction in a synchronous machine, what you are going to do? You will see what is the effect or the nature of armature reaction for the extreme conditions. What is our approach? Our approach is, we will see what is the effect of armature flux on the main field flux, that is the armature reaction for the extreme conditions, and from those extreme conditions we will draw some generalization and we will assume that these generalizations are going to be the nature of armature reaction for different power factor or load conditions. Is it clear to all of you? This is the reason why we are taking different cases: zero power factor lagging, zero power factor leading, and unity power factor. Is it clear to all of you? Please tell me yes or no in the comment section. This thing you should understand that why we are taking these extreme cases. Now, what are the extreme cases? You listen to me very properly. What are the extreme cases? You listen to me very properly. When I am saying the zero power factor lagging condition, can you tell me what is the meaning of zero power factor? Can you tell me what is the meaning of zero power factor? Now let me give you one impedance diagram. Let me give you one quick impedance diagram. Now see, this is going to be R, this is going to be X, and this is going to be Z, and this is angle phi. Yes or no? This is nothing but your power factor angle. If I am saying zero power factor lagging, what does it mean? It means cos phi is going to be 0. Now when cos phi is going to be 0, when this angle is going to be 90 degree, because cos 90 is going to be 0. Now you tell me when this phi angle is going to be 90. This phi angle is going to be 90 when this R is going to be almost 0. Is it clear to all of you? It means for these zero power factor lagging and leading case, one thing is 100% clear, that you are assuming R is equal to 0. Resistance is equal to 0. Is it clear or not? When you are saying unity power factor, again one extreme case, unity power factor, what is the meaning of unity power factor? It means cos phi is going to be 1. When cos phi is going to be 1? When this angle phi is going to be 0. Now when this angle is going to be 0, this angle is going to be 0, if you take this Z line closer to the R line, it means X should be 0. It means you are taking this condition for X is equal to 0. Yes, Vicky Kumar, you are perfectly right. Now all of you please tell me, do you understand all these three extreme cases? Zero power factor lagging, zero power factor leading, and unity power factor. What is the practical significance of this? Now you listen to me very properly. Very important point I am going to tell you. We are assuming that for the generator, all the armature resistance and leakage reactance, everything we are assuming 0. We are neglecting them. So what we are going to do, we are going to have the terminal voltage of the alternator and the excitation EMF the same. Their magnitudes are going to be same. All the cases. Can you see this? Yes or no? Now the practical understanding of the armature reaction, in just one shot I am going to tell you. What is the practical significance? When you are saying zero power factor lagging, the first information is for the load connected resistance is going to be 0, and because it is lagging, so the current drawn from the generator is going to be lagging to the terminal voltage or the excitation EMF by 90 degree. That we call as zero power factor lagging condition. First point. Second point, figure number B. When we are saying zero power factor leading condition, it means the armature current drawn from the generator is going to lead the synchronous alternator excitation EMF or the terminal voltage by 90 degree. So you can see the corresponding phasor diagram also. In this diagram, the armature current is going to lead by 90 degree the excitation EMF or the terminal voltage. Is it clear to all of you? Are you comfortable with this? Please tell me yes or no in the comment section. These two cases, are you comfortable or not? Are you comfortable with this or not? Please tell me yes or no in the comment section. This is very important. Then we can proceed. Then we will try to understand each and every case in detail. First you tell me whether it is comfortable for you or not. Now you listen to me properly. Very important point I am going to tell you. All of you just put your ears near to the speaker. Everybody, listen to me. I am saying if this armature current is lagging the terminal voltage or the excitation EMF by 90 degree, because we are taking the zero power factor lagging condition, it means the flux due to this armature current is going to be in opposition to this field flux. This is the field flux, and this we have discussed in our previous classes, that the excitation EMF is going to be lagging the main field flux by 90 degree. The reason behind, now let me tell you, what is the overall story? The story is, you are having a rotor which is rotating, which can rotate. In that rotator, you are having field winding, and that field winding is given the DC excitation, and now you are rotating that rotor with the prime mover. At what speed? At the synchronous speed. Now this field flux is going to cut the armature winding which is put on the stator, and there is going to be some induced EMF that we are calling as excitation EMF in the armature windings, and in this armature windings, if the load is connected, there is going to be some current because of this induced voltages. Now the moment there is current in the armature winding on the stator, it is going to have its own MMF, its own flux, that we are calling as armature flux. I hope it is clear to all of you. Now for the first case, zero power factor lagging condition, we have seen that this armature current is 90 degree lagging to the terminal voltage, and your field flux, main field flux phi f, is going to lead the excitation EMF by 90 degree. So very easily you can say that for this case the armature reaction is going to be demagnetizing. Yes or no? If the armature flux is going to be in complete opposition to the main field flux, then it is going to be completely demagnetizing. Is it clear or not? Tell me yes or no in the comment section. I hope it is clear. Come to the second point. Second case, zero power factor leading condition. What is the practical understanding? The practical understanding is the armature current is going to lead the terminal voltage or the excitation EMF, and if the armature current is going to lead the excitation EMF or the terminal voltage by 90 degree, therefore this armature current is going to be in the same phase of the main field flux, and the flux due to armature current is also going to be in the same direction. So for this zero power factor leading condition, you can say the armature reaction is going to be magnetizing. Is it clear or not? Is it clear or not? For the first case we have seen the armature reaction is going to be demagnetizing. For the second case we have seen the armature reaction is going to be magnetizing. Now we are coming to the unity power factor. Unity power factor means the armature current is going to be in phase with the excitation EMF or the terminal voltage. Yes or no? Is it clear? Now this armature current is going to have a flux, and this flux is going to be, I am writing as almost cross magnetizing. Is it clear to all of you? Is it clear to all of you? Please tell me yes or no in the comment section. I hope it is clear to all of you. Now, why I am writing this as almost cross magnetizing, not the exactly 100% cross magnetizing, that reason I will tell you later. You keep it for the future. I will answer that question later. Now you please focus and try to listen to me. And if you understood this point, you tell me yes or no in the comment section so that we can proceed. Is it clear to all of you? Benson, Thomas, Manoj, Moni, Gonda, Kavya. What about the rest of the candidates? Now see, if I am this much energetic and you are not energetic, then it is not going to happen. Both the hands have to come with the same force, then only there is going to be some sound production. So if you want to have a sound production, if you want to have results, then you have to be proactive and you have to be energetic. Whenever I ask you something, Ranjit Mahal is saying, sir, please repeat the unity power factor. Okay, now you listen to me. I am saying unity power factor means that the current is going to be in phase with the terminal voltage or the excitation EMF. That is the first point. And I am saying that the effect of armature reaction is going to be almost cross magnetizing. Why I am not writing cross magnetizing, this reason I would tell you later, not right now. You just understand it. Right now you can understand this point that for unity power factor you can assume the nature of armature reaction to be cross magnetizing. Now why I am putting this keyword almost cross magnetizing, that reason I would tell you later. Is it clear to all of you? I hope it is clear. Now let us start with this. Now whatever we have discussed, you just leave it apart and you listen to my story with all your concentration. First thing, in the yesterday class we have discussed field winding that is going to be on rotor for the synchronous machine. This field winding is going to give rise to a flux which we are calling as phi F. That is main field flux. Yes or no? What is the reason of this field flux? The reason of this field flux is field MMF. What is this field MMF? This field MMF is NFIF, number of turns of the field winding and the current in the field winding. Yes or no? I hope it is clear to all of you. Now this thing we have already understood in the yesterday class, that the EMF which is going to be induced, where this EMF is induced? This EMF is induced in the stator armature winding. Stator armature windings. And let me tell you, it is going to be a three-phase winding. This we have discussed when we were discussing the construction details about the synchronous machine. The stator armature winding is going to be a three-phase winding. So this EF is going to be induced in the stator. Now the first case we are taking is the no load operation. What is the meaning of no load operation? When we are saying no load operation, it means there is no load connected at the armature winding terminals. When the no load is connected at the armature winding terminals, then the current drawn from that alternator or the generator is going to be zero. Because no load is connected, and I have already told you that all the time you are going to characterize the load in terms of current. So no load means no current drawn. It means if you are rotating the rotor with the help of the prime mover at the synchronous speed, there is going to be the excitation EMF induced in the stator armature winding, three-phase windings. But because no load is connected, there is not going to be any current. This is the overall story for the no load operation. Now, I have told you that this EF is going to lag the flux phi F by 90 degree. And the derivation for this concept we have already understood yesterday. If you have any doubt, then I can discuss it again. I hope it is clear to all of you. And if you want to do it on your own, then you can do it. Because this field flux I am writing as phi is equal to phi m sin omega t, and this excitation EMF if you want to write, then it is going to be minus n d phi by dt. So if you do this derivation, then you will get that this excitation EMF induced in the stator armature winding is going to be lagging by 90 degree to this field flux phi f. So this is the diagram you are having when you are having the no load operation. Is it clear to all of you? Please tell me yes or no in the comment section. This is the first case, that is the no load operation. Is it clear? Is it clear to all of you? Please tell me yes or no in the comment section. Now we are going to discuss the second case. What is the second case? The second case is going to be the unity power factor. Is it clear? First case we are taking as unity power factor load condition. Now all of you just listen to me. I am going to draw some beautiful diagrams and you just focus, have patience to see my beautiful diagrams. It is going to be very helpful for you. Is it clear? Now you see, suppose this is your rotor. This is your rotor. And let me tell you, whatever armature reaction we are discussing only about the cylindrical rotor. You please keep this thing in your mind. Whatever armature reaction we are discussing only for cylindrical rotor, not the salient pole. Is it okay? Salient pole story already over, that we have covered. Now you focus here. Suppose this rotor is going to be, if it is a cylindrical rotor, then it is going to have some windings, yes or no, field windings in the slots, and suppose it is something like this. It is something like this. These are the field windings on the cylindrical rotor. Something like this. Now here I am going to have dots and here I am going to have cross. Yes or no? And now I am going to put the armature winding A phase. One phase we are only taking. I will tell you the reason why we are considering only one case. Now suppose this we are calling as A and this we are calling as A dash. A we are having a dot and A dash we are having a cross. This is the case for the unity power factor load condition that we have discussed earlier. Now you listen to me very properly. If this is a cylindrical rotor, can you find the field flux direction or field MMF, yes or no? You apply the right hand rule. How you are going to apply the right hand rule? The fingers of the right hand are moving in the direction of the current sense and your thumb is going to point towards the flux direction. Is it clear or not? So this is going to be for this cylindrical rotor, this is going to be your field flux. Yes or no? This is going to be field flux. You can say FF or you can write as phi F also. Are you getting this idea? You apply the right hand rule and this I am writing for these field windings at the rotor. That is going to give you the main field flux. Now if there is some load connected and that I am calling as unity power factor load condition, then the current in the A and A dash coil for the A phase is going to be such that if you again apply the right hand rule for the A and A dash phase, the current is coming out of the plane of the screen and going from A and it is going into the plane of the screen at A dash. So if you apply the right hand rule, then your armature flux is going to be in which direction? It is going to be in this direction. Something like this. This we are writing as FAR. Is it clear to all of you? Now if you see, listen to me properly, if you see this area is going to act like because of the field winding, this area is going to behave like a north pole because of the rotor windings, field windings, and this area is something going to behave as the south pole. Are you getting this idea or not? for the field winding. Yes or no? Are you getting this idea? So if you see, suppose I am trying to know the resultant flux. So this resultant flux is going to be something like this. I hope it is visible to you. So this is going to be Fr. What is Fr? The resultant of main field flux and the armature flux. Is it clear to all of you? Yes or no? Now see this pole, you please focus here, all of you listen to me very properly. This is going to be very, very important. This part of this north pole we are saying as trailing pole tip. Yes or no? Ranjit Mahal, what is your doubt, beta? Please tell me. If you have any doubt, then you can ask me. Otherwise, listen to me properly. Now you listen to me properly. This we are calling as trailing pole and this we are calling as leading pole. And this is the direction of rotation. This is the direction of rotation. That is the anti-clockwise rotation with the synchronous speed. This we are calling as the leading pole. This we are calling as the trailing pole. Now you listen to me properly. Because of the effect of armature flux on the main field flux, the resultant flux is concentrated on the trailing pole. So you can write the resultant flux is concentrated at the trailing pole tip in case of a generator. I hope it is clear to all of you. It is very important point. Ranjit Mahal, what is your doubt, beta? You please ask me. If you are not getting it, I am ready to explain you n number of times, but you have to tell me what is your exact doubt. Now you listen to me properly. Now we have understood for the generator. This was the case we were discussing as generator, and now we are going to discuss about the motor. Now we are going to discuss about the motor. I hope this generator, unity power factor condition, armature reaction is okay for you. Now we are going to discuss the motor. How I am going to discuss the motor? Just see here. Again I am going to have a rotor. Yes or no? Again I am going to have a rotor. These are the field windings. Here I am going to have dots. Here I am going to have crosses. And this is going to be your A phase coil. This is A and this is A dash. Now if I am discussing right now the case of the synchronous motor, all of you please tell me what is the change. What is the first change you are going to observe if you are going from a generator to motor? What is the first change you are going to observe? The first change is the direction of armature current is going to be reversed. If you go to the previous slide, if you see the case of the generator, I am taking dot for the A coil and for A side, A dash side, I am taking the cross. If I have to reverse this case for a motor, so I have to reverse the direction of current, and this current is going to be taken from a supply. Yes or no? Are you getting this idea? For a generator it is supplying current, for a motor it is absorbing current from the supply. So what I am going to do to understand the case of the armature reaction for unity power factor load condition for a motor, I am just reversing the armature current in A phase. So if I am having dot in A, cross in A dash, so now I am going to have dot in A dash, in cross in A. Is it clear to all of you? So here I am going to have cross and here I am going to have dot. I hope it must be clear to all of you. Benson Thomas is saying, sir, how we got the north and south, please explain. Definitely I will explain. First you listen to me. If you understand this case, then you will understand how the north and south pole has been generated. Is it clear? You listen to me properly. Now I am asking you to focus on this rotor windings. Rotor windings are nothing but field windings. Again, Benson Thomas, you focus on my right hand. You are going to apply the right hand rule for the currents in the field windings at the rotor side. How you are going to apply? You move your fingers in the direction of the current sense. What is the current sense? The current is coming from the dot and it is going into the cross. So the current sense is going to be like this, and your thumb is going to point toward the MMF or the flux direction. I hope it is clear. So this winding, this field winding at the rotor side is going to give effect to this rotor as if there is north pole and there is south pole. This is how poles are being generated. Is it clear? Again, my dear, you are having the main field flux in this direction. Again, you are having the main field flux in this direction. This we are calling as FF, main field MMF. And now if you see the current sense in the armature coil AA dash, it is now being reversed. So if you apply the right hand rule in the direction of current sense, current is coming from the dot and going into the cross, and your thumb is going to point towards the MMF or the flux. So what is the direction of your armature flux? Please see here, it is going to be in this direction. This is going to be the direction of armature flux. I know it is little difficult to understand from this pen and tablet mode, but I am giving my 100% to make you understand all these phasor diagrams. I don't know how much you are getting, but let me tell you very frankly, I am giving my 100%. And still, if you want some improvement, then you are most welcome to ask your doubts. Now this is going to be your resultant MMF FR. Something like this. So if it is a motor, I am not reversing the direction of rotation of the rotor. Suppose this is NS. So again we are calling this as the trailing pole tip and this we are calling as leading pole tip. Yes or no? Now you focus here. What I am saying, for a motor I am saying the resultant flux is concentrated at the leading pole tip. You have to remember this statement. This can be directly asked in small exams. In GATE and engineering services also it can be asked, and this statement about the motor and the previous statement about the generator you have to remember about the armature reaction. Prajwal Kumar BV is asking how to manage the semester exams and GATE exam preparation. Now Prajwal, I am going to give you one very simple solution. You are going to get something out of the GATE examination once you have completed your B.Tech. So what is your priority? Your B.Tech semester exams. Is it clear to all of you? Suppose you got rank 1 in the GATE examination, GATE 2021, and somehow, may God forbid, I am not talking about you, for anybody else, if it is not possible for him to clear his semester examination, so it is going to be a little difficult. This is the first story. What is the second story? The second story is, if you are preparing for the GATE, you are studying technical things. If you are preparing for semester exams, you are also reading the technical things. It means now it depends on you how you can converge your GATE preparation and the semester preparation so that your first priority is semester exam and the next most important priority for you is GATE examination. Is it clear to all of you? Please tell me yes or no in the comment section. Prajwal, I think you are getting my idea. Now you listen to me, very important point for the armature reaction for the unity power factor load condition. I am going to write it here. All of you just focus here. For unity power factor, if you see, the armature flux is going to be at 90 degree, whether it is generator or whether it is the case of motor. The armature flux is always going to be at 90 degree to the main field flux. So we can conclude that armature flux is going to be always at 90 degree to this main field flux. So you can say the nature of armature reaction, beta, it is going to be cross magnetizing. It is going to be cross magnetizing. Now in some of your interviews, if you clear your GATE examination with a very good rank and if you clear your written examination of the engineering services, you go to the UPSC interview. Let me tell you, if he asks you what is the cross magnetizing effect of the armature reaction, then you just tell him one word, that is called as distortion. Cross magnetizing effect of the armature reaction is nothing but the distortion of main field flux. If you want, then this statement you can write in your notebook. There is something important for your notebook, that is, the cross magnetizing effect of the armature reaction is nothing but the effect of distortion on the main field flux because of the armature flux. I hope it must be clear to all of you. Is it clear to all of you? Is it clear to all of you? Now you see the phasor diagram. Now you see quickly the phasor diagram. Quickly we are going to see the phasor diagram and you will understand very quickly because rest all things we have discussed very effectively. This is going to be your main field MMF, main field flux, and your this is going to be armature flux or the armature MMF, and this is going to be resultant MMF or the resultant flux. So you see your armature flux or MMF is going to be 90 degree to main field flux, so it is going to be cross magnetizing. I hope it is clear to all of you. Now if you add the excitation EMF in the armature current also, then you are going to get this phasor diagram. The excitation EMF is lagging the main field flux by 90 degree. Why? We have discussed. And if the armature current is also lagging this by 90 degree, so you can say your armature current is going to be in phase with your excitation EMF. That is why we are calling it a unity power factor load condition. This we have discussed earlier and this is now we have concluded for the unity power factor load condition. I hope it is clear to all of you. I hope it is clear to all of you. Now we are going to discuss the zero power factor lag condition. Now we are going to discuss the zero power factor lag condition. All of you please tell me, are you comfortable with this? And if you have any doubt, then you can ask me. Now we are going to discuss the zero power factor load condition. Now again I am going to take the cylindrical rotor. Is it clear? Again I am going to take the cylindrical rotor, and again I am saying that there is A phase coil, something like this. This is A and this is A dash. And for the case of generator I am saying this is going to be dot and this is going to be cross. Is it clear? Now what we are going to do, At this case, zero power factor lagging condition. Suppose your field or rotor winding coils are something like this. Okay. Now your field coil current direction I am writing as dots here, cross here. So what is, if you apply your right hand rule, current coming from the dots going into the cross. If you apply your right hand rule, so what is going to be the MMF or field flux direction? Field MMF or field flux direction, it is going to be something like this. Yes or no? This is going to be your main field MMF. And if you see the current in the armature coil A phase AA dash and you apply your right hand rule, then it is going to be, the armature flux is going to be in complete opposition to this main field flux, something like this. It is going to be something like this. This is going to be your FAR. Are you getting this? Now, if this is complete opposition, this angle is 180 degree, armature flux is lagging the field flux by 180 degree, then you can say it is going to be demagnetizing. What is the meaning of demagnetizing effect of the armature reaction? Somebody can ask you in the interview, what is the effect of demagnetizing effect of the armature reaction? You can call it weakening of the main field flux. Weakening of the main field flux. Moli Manikanta is saying, sir, field flux perpendicular to armature flux, the only case of salient pole rotor. Moli Manikanta, you better please wait. You just listen to me. First you understand for the cylindrical rotor, then whatever doubt you are having for the salient pole, then I am going to take it. Okay, first you cover this up. First we will cover the whole armature reaction concept, and then if you have any doubt, I will discuss that with the salient pole machine also. Is it clear to all of you? Now, what is the effect of demagnetizing armature reaction? Demagnetizing armature reaction is nothing but the weakening of the main field flux. That is what we are calling as demagnetizing effect. And this we are saying for the generator. Now, let us see what is the case for motor. If you see the case of motor, let me write the case of motor here. For the case of motor, again what you are going to do? You will keep the field flux current direction same and you will change the direction of armature current in the A phase coil, yes or no? So this is going to be A and this is going to be A dash. This was initially dot, so now we are taking as cross. This was initially cross, so now we are taking as dot. And these are the field windings. And what is the current sense in the field windings? These we are taking as dots and these we are taking as cross, as the earlier case for the generator. Now we are taking as the motor. Now if you apply your right hand rule for the field winding at the rotor, so your field flux is going to be in this direction. This is going to be your field flux. Okay, and what is going to be the direction of armature flux? Again apply the right hand rule. So your armature flux is again going to be in the same direction that of the main field flux. I hope you are getting this. And this is your FAR. So you have to add this FAR in this so that you get the resultant armature resultant flux or MMF, FR. I hope it is clear to all of you. Is it clear? Is it clear to all of you? Please tell me yes or no in the comment section. Is it clear to all of you? Now I am going to tell you one very important point. What is that point? You come here. If you see this demagnetizing armature reaction effect for the generator zero power factor lag condition, if the armature MMF is going to oppose the main field flux, it means if you put it here, so it is going to be something like this. This is going to be your armature reaction. Sorry, this is going to be your armature flux, and this is going to be your resultant. This is going to be your resultant MMF, that is FR. This is going to be your FR and this is going to be FAR. Is it clear to all of you? Now I am going to tell you one very important point. For the case of generator, you keep all the points which I am making or highlighting in your mind. You draw a mental map. For a case of generator, we are having this field flux, this main field, sorry, not flux, MMF, FF more than the resultant MMF, that is FR. This we are calling as over excited condition. Whenever the main field flux is going to be more than the resultant flux, then we are calling it as the over excited condition. Now come to the motor case. If you come to the motor case, the main field flux is going to be less than the resultant flux. This we are calling as under excited condition. And what are these under excited and over excited conditions? This we have discussed in our earlier classes. So if you have not attended them, you please attend them. I hope it is clear to all of you. Is it clear? Tell me yes or no in the comment section. Now if you see, this is the phasor diagram we have drawn. This is the phasor diagram we have drawn for this zero power factor lag condition. We have drawn it for the case of generator. Okay, I hope it is now very easy to understand and you can understand it. That your armature MMF, armature current or armature flux is going to be 180 degree opposition to the main field MMF or the armature flux. So it is going to be this much. Is it clear to all of you? Now we are going for the zero power factor leading condition. Now let us see zero power factor leading condition. Again I am going to draw the rotor. And first we are going to discuss for the generator and then we are going to discuss for the motor. So for the generator, first we are discussing, this is your A phase coil, A dash, this is going to be dot and this is going to be cross. Is it clear? And this is going to be your field windings and this is going to be the current sense. Zero power factor leading load condition for the generator I am going to discuss. Okay, so it is going to be something like this. So again, if you apply your right hand rule, I am saying for the rotor field winding. So what is going to be the direction of your main field flux? It is going to be something like this. This is going to be your main field MMF. And again, if you apply for the AA dash stator armature winding A phase coil, current sense, if you apply the right hand rule, then you are going to get the direction of armature flux or MMF in this direction, same direction, because the current sense is same. This is going to be your FAR. So if you want to know the resultant MMF, so you have to add them both because they are in phase. This we are calling as FAR and this we are calling as the resultant MMF. This is going to be your resultant MMF, FR. Is it clear to all of you? Now you can see it is going to be magnetizing. Yes or no? It is going to be magnetizing. If you see the case of motor also, when we were discussing the zero power factor lag condition, the idea is zero power factor lag condition for the generator is similar to the zero power factor lead condition for the motor. What I am saying, zero power factor motor condition is going to be similar to zero power factor lead condition for the generator. Reverse case it is same. So this is also magnetization. Okay, the effect of armature reaction is magnetization. Now what is the magnetizing effect of the armature reaction? This we are calling as a strengthening of the main field flux. If somebody asks you in any interview what is the meaning of magnetizing effect of the armature reaction, that is nothing but the strengthening of the main field flux. I hope it is clear to all of you. Again, one important thing, your field flux MMF is going to be less than the resultant MMF. So you can write it as the under excited condition, and this we are reading for the case of generator. Is it clear to all of you? Now the same case we are going to discuss for the motor. Same case we are going to discuss for the motor. Again I am drawing it here, all of you just see. This is going to be your field coils at the rotor side, and this is going to be your stator armature winding A phase coils. Now the field current sense, field winding current sense, you are not going to reverse. For a motor, generator to motor transformation, you will only reverse the current in the field, in the armature winding. Armature winding currents are going to be reversed. Field is same, so field is going to be dot, 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 cross, 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 and this is going to be cross, and this is going to be dot. Is it clear? Now what is happening, if you see for the main field flux is going to be something like this. This is going to be FF. Again, if you apply the right hand rule for the A-A coil, so the direction of armature MMF is going to be something like this, in phase opposition, complete opposition to this main field flux. This is going to be FAR. So what is going to be your resultant? What is going to be your resultant MMF? This is going to be FAR. So what is going to be your resultant? This is going to be your resultant MMF. Again you see FF is more than FR, and this is for the case of motor. So you can write it is going to be over-excited condition. Is it clear to all of you? Please tell me yes or no in the comment section. And this is going to be if your armature flux is opposing the main field flux, so it is going to be again demagnetization or demagnetizing effect of the armature reaction. All of you, please tell me in the comment section, is it clear for you? Are you comfortable with this understanding or not? Please tell me yes or no in the comment section. Are you getting this idea? Are you getting this idea? And let me tell you, this phasor diagram we have drawn for the generator case. This we have drawn for the generator case, and this is the motor case. So don't correlate motor case with the generator case. You correlate generator case with the generator case, motor case with the motor case. I hope it is clear to all of you. Okay, now I am going to summarize the armature reaction for you. All of you just listen to me properly. I am going to give you a quick summary of the armature reaction so that you can take the snapshot and you can remember it, and you just reread whatever we have discussed tomorrow, and in the tomorrow class we are going to discuss some more important points about the armature reaction. All of you just listen to me properly. Now I am giving you a complete summary of the armature reaction that you can take the snapshot, and if you want to note, then you can note it down also. Very beautiful table I am going to make. You can see how efficiently I can make tables to learn difficult concept to my students. Okay, so here we are having power factor, here we are having alternator, or you can say generator. This is the case of generator. Alternator is nothing but generator, and this is your synchronous motor. Is it okay? So first case we are taking unity power factor. For the unity power factor we have seen it is going to be purely cross magnetizing. Purely cross magnetizing. Yes or no? And for the motor also it is going to be purely cross magnetizing. This is first case for unity power factor. Second, we are going to take zero power factor lag condition. Zero power factor lag condition, listen to me properly. For the alternator we have seen zero power factor lag is going to be purely demagnetizing, and if you go for the synchronous motor it is going to be purely magnetizing. If you go to the zero power factor lead condition, zero power factor lead condition, then for the generator it is going to be purely magnetizing, and for the synchronous motor it is going to be purely demagnetizing. Is it clear to all of you? Now we have seen the extreme cases. What are the extreme cases? Extreme cases are unity power factor, zero power factor lag, zero power factor lead. Now we are going to take practical cases. What are those two practical cases? Who is going to guess? It is going to be 0.8 power factor lag. Okay, it is not unity power factor, it is not zero power factor, it is practical situation. 0.8 power factor lag condition, 0.8 power factor lead condition. Now it is very important that you understand this point which I am going to make. If you want to know the effect of armature reaction for 0.8 power factor lagging, then you have to take some effect for the unity power factor and some effect for the zero power factor lag condition. It means your armature reaction for the alternator is going to be partly, or let me write it in a more broader sense so that you can remember it, partially. It is going to be partially cross magnetizing. I am writing cross magnetizing effect of the armature reaction as CME, and partially it is going to be demagnetizing effect. This is how I am writing demagnetizing effect. When you are going for the synchronous motor, again it is going to be partially cross magnetizing effect, and it is going to be partially magnetizing effect. It was demagnetizing effect, it is magnetizing effect. Now for 0.8 power factor lead condition, again it is going to be partially cross magnetizing effect and partially magnetizing effect. For the motor, it is going to be partially cross magnetizing effect and partially demagnetizing effect. Is it clear to all of you? Just take the beautiful snapshot and remember me when you get a direct question on this. Is it clear to all of you? Now I am going to conclude today's class, and we are going to discuss some of the remaining portion of the armature reaction. This is the conventional approach what we have to understand, but there are some points remaining which I want to discuss with you, that I am going to discuss with you tomorrow. And tomorrow, what is the topic we are going to have? Let us see what is the topic tomorrow. We are going to discuss, apart from some important points about the armature reaction, we are going to discuss the methods to calculate the voltage regulation of the synchronous machine, or basically alternator, not machine. We always go for voltage regulation for the synchronous generator. Yes or no? So please tell me yes or no in the comment section. Now are you feeling little bit confidence in the armature reaction of the synchronous machine or not? And don't forget to join me tomorrow. I am also, now there is one more important information regarding the 60 students in the top 100 students in the GATE 2020 examination, and if you want yourself to be in this panel, then my dear, you have to do two things. Number one is hard work, and what is second thing? Second things you all know is nothing but hard work. There is no substitute to hard work. You have to do hard work. Is it clear to all of you? So friends, thank you so much for your time. I wish you all the best, and we are going to meet tomorrow to discuss the voltage regulation methods for the synchronous alternator. Don't forget to join me at 8:30 p.m. only on the YouTube Gradeup GATE channel. One last thing I want to tell you, all the candidates who are interested to understand power system, right now I am taking a free series. It is free of cost as concept on fingertips for power system on the Gradeup app, and I have just taken 2 classes. And if you understand power system from there, let me tell you, you will get a completely new dimension about the power system. I have just completed 2 lectures. First lecture I have completed on 11th May, and second lecture I have completed today, that is 12th of May. So if you want to join me tomorrow, 13th of May, the timing is 12 p.m. in the afternoon. You can attend and join me on the Gradeup app, but you have to go to the Gradeup app. You have to register yourself as a student electrical engineering. Then there is one information regarding this concept on fingertips power system, free of cost classes. You can enjoy learning power system in the most simplest language. Thank you so much friends. I wish you all the best for your upcoming exams. Stay safe, stay in your home, follow the government regulations, and lastly, prep smart, score better, go Gradeup. Thank you so much. Vasisht Muthireddy is asking which topic of the power system. So tomorrow I am going to discuss power in a 3-phase circuit. Let me tell you, these classes are very interesting classes. The duration of these classes is just 30 minutes. Within this 30 minutes, I will try to explain one concept with 100% concentration, both the sides, from my side and from your side. So it is going to be very productive. If you have any doubt, any inclination to learn power system, you can come on the Gradeup app and you can join me for these lectures. These are free of cost lectures and it is going to be very insightful, very informative and very productive. So friends, thank you so much for your time. I wish you all the best again, and we are going to meet tomorrow 8:30 p.m. in the evening only on the YouTube Gradeup GATE channel. Thank you so much for your time. I wish you all the best.